All right, in this video we're going to work together to complete the SPSS Workshop. By this point you should have purchased your own copy of SPSS. It should be on your computer and tested to make sure that it is working properly. Now in this workshop you're going to use SPSS to conduct a simple analysis and report the findings in the form of a PowerPoint presentation. The finished product will look very similar to an academic conference presentation. The purpose of this workshop is to expose you to the basic functions of SPSS and give you the opportunity to apply your skills to an authentic research context. Additionally, the presentation you create in this workshop will be very similar to your final project. In your final project, you will implement the skills you learned in this workshop independently and demonstrate your mastery of the course content. To participate in the workshop, first download the SPSS Save Data file to your computer and open it in SPSS. Also open the PowerPoint template up on your computer. And this is where we're going to jump in. So the PowerPoint template looks like this. We've got blinks and dots and X's throughout the template. We're going to fill those in together. I'm going to show you exactly what to do. You just have to follow along with me. I also have the data set downloaded to my computer and opened up, and we're going to use this as well as we go through the workshop. So let's start by taking a look at the data set. In this data set, we have 1, 2, 3, 4, 5, 6, 7, 8 columns, and each column is a variable. The first column is an ID column. So this is not a variable that you would be analyzing. This is simply a participant ID number. So what's happened is these are real data from an actual data set from a different study that I participated in earlier on. And these simply numbered the participants. I believe it was an online survey. So everyone who took the survey got a number. And we simply have all of the participants numbered. There's some that are missing. We have some participants who've been omitted for various reasons. So number 10 you can see is not there. Number 1 is not there. There's probably some other instances. But we're not going to worry too much about this. Really, we won't use the ID variable at all. It's simply to help organize and keep track of our data. So that's what we have in the first column. Let's see, the next variable is age. This is a ratio level variable, or what SPSS calls a scale level variable. So if we go to the variable view, I just click from data view to variable view, we see that age is a numeric scale level variable. It's not coded. It's simply, click back over here, it's simply the participant's age. So 31 means that this is a 31-year-old person. Here's a 61-year-old person, a 27-year-old person. This person is 76 or a little bit older, and so forth. The next variable is gender. This is a nominal variable. So this is scale or ratio level variable. This is a nominal or categorical variable. So if we click to the variable view and take a look at gender, we see that it is categorized as a nominal measure. That means they're just groups. There's no order to them, as with an ordinal variable, also as with a scale level variable. And this variable is numeric. So you might think, well, how is that? We have a numeric variable, but gender is not numeric. It's male or female. So what's happened here is we have coded this variable using numbers to represent the different groups. So when I click on the values box here, we see that there are two different groups, female and male. Female has been coded with a 0 and male has been coded with a 1. So what we're telling the computer here, what we're telling SPSS, is whenever we type a 1, what we mean is this participant is male. If we type 0, we're saying that the participant is female. So when we go back over to the data view, we see male, female. I can toggle this between the code and the meaning of the code, clicking this button here. So I can click between 0s and 1s and male and female. But what was actually entered into the computer was 0s and 1s. But because it's been coded, and using the values option right here, because this is here, it can be displayed, it can be displayed as male and female. There we go. The next 5 variables are survey responses. So on the survey, there was a large survey. There were many other variables. I'm only presenting some of them to you in this data set. So I've deleted hundreds of other variables. But here we have their ID number, their age, their gender, and these are 5 responses to the life satisfaction scale. So this is a short 5-question survey that asks them about how satisfied they are with their life. If you're interested, this is what the scale looks like. So there are 5 items. In most ways, my life is close to ideal. The conditions of my life are excellent. I am satisfied with my life. So far, I've gotten the important things I want in life. If I could live my life over, I would change almost nothing. And these are the response options, 7 through 1. So if they strongly agree with the item, they would put a 7. If they strongly disagree, it's a 1, and anywhere in between. So I am satisfied with my life. If they say, oh, yes, very much so, they put a 7. If they say, oh, absolutely not, I am completely unsatisfied with my life, they would put a 1. So these 5 variables correspond to these 5 questions. So if we were to take a look at this person right here, participant number 5, this is a 28-year-old female, and she put 77777. So she strongly agreed with all 5 of these statements. I would change nothing about my life. I've gotten the important things. She strongly agrees with this. But look at this person, number 7. She put 11111. Very dissatisfied. Usually you see kind of a combination of responses. So here's 3, 2, 2, 1, 2, kind of on the lower side. But that's what that means. Okay. So this is what these variables indicate, and let's go ahead and move forward, shall we? So we have the data set here. These, oh, by the way, these are ordinal level variables. So take a look at all 5 of these under level of measurement, right? So there's a nominal. So the ID is nominal, even though they're just numbers in order. Well, aren't they in order? Why wouldn't it be at least ordinal or scale level? Well, it's because they're arbitrary. These don't mean anything. 11 is no more than 7. 2 isn't less than 31. They're just different numbers to represent these people. So that's nominal or categorical, as is gender. Again, even though we've coded them 0 and 1, it doesn't mean that males are more than females. Females are worth nothing and males are worth 1. That doesn't make any sense at all. They're just arbitrary numbers. We could have picked anything, 77 and 4, or 113.921 and 6. Doesn't matter, they're just different groups. That's why those are nominal. Scale is age, because the intervals between years is always the same. There's always 12 months in a year. So somebody who just turned 20 is 12 months older than someone who just turned 19. Someone who just turned 106 is 12 months older than someone who just turned 105. Now here we have ordinal, which means there is an order to the responses. Right? Remember what our response options were? Strongly agree to disagree. So 7 is more than 1. If you put a 7, you are more satisfied with your life than someone who put a 6 or someone who put a 3 and so forth. The difference is that the distance from agree to strongly agree isn't necessarily the same as the distance from neither agree nor disagree to slightly agree. We have no way of knowing that the gap between 4 and 5 is the same as the gap between 5 and 6 and so forth. So these are ordinal level measures, right? So that is the data set we'll be working with. Now let's take a look at the template. Some of the template has already been filled in for you. The rest we're going to fill in and work out together so you can learn the process. This is basically what a conference presentation would look like. So if you're going to present your findings at an academic conference, there are all different sorts of academic conferences, and this were what's called a paper presentation. I should clarify that. This is how it would look. There's also something called a poster presentation, which might be, it looks kind of like what you would see at a school science fair, maybe in grade school, where all the information is on one big poster paper. This would be what's called a paper presentation, where you would get up in front of a group of people. Usually it's a group of, I don't know, it could be 10, 15, 20 people. and you would present the results of your study. And it might be a 20, 30-minute presentation, and you'd walk through all these different components. So giving the name and the context for the study, describing the study in the methods section, going through the results of the study, and of course discussing the findings and the implications of the study. So the very first slide you're going to begin with is just basically your title page. So here we have the title of the presentation, or the title of the study, the author's name, and the institutional affiliation. If you were doing this for a class, you would not put the professor's name, right, unless they were a co-author on your paper. But if they're not a co-author on your paper, their name's not going to appear. You're also not going to include the date. So the title, what's the title of this study? Well, in this workshop, we're going to be looking at gender as a predictor of life satisfaction. So we have a gender variable. We have two groups, male and female, right? Two genders, male, female. And then we have life satisfaction. Now, we're not going to be able to work with it in this form. We'll get to that, how we're going to end up working with this construct, life satisfaction. But in terms of the variables we're interested in, is gender as a predictor of life satisfaction. So it wouldn't be apparent just from looking at this. I'm explaining that to you as you follow along in the workshop. That's what we're going to be doing. So I'm going to go ahead and write that in. Gender as a predictor of life satisfaction. Just like that. Now, say a little more about this title. What we've used here is correlational language as a predictor of. As a predictor of, because this is not an experiment. This is a correlational study. So you want to be very careful about drawing causal inferences from a correlational study. We're going to look at the relationship between these two variables as they already existed. We have not experimentally manipulated anything. We haven't changed the independent variable, gender. So the independent variable is gender, the dependent variable, life satisfaction. We haven't manipulated their gender. Right? We haven't randomly assigned participants to be either male or female. They simply already are male or female, and they already have some level of life satisfaction. We may have a theory about gender influencing life satisfaction, but we're not going to draw that causal influence in our title because we can't necessarily establish that because of the nature of the study. So gender as a predictor of life satisfaction. Now, what else appears on our title page? The author's name. So if this is your presentation, you're going to put your name. I'm going to put a fictional name. Actually, I'm not going to put the last name student. That might confuse someone. They think they're supposed to put their name and then the word student. So we're going to have Joe Smith be our fictional author. In APA, there's no titles. So you wouldn't put Mr. Joe Smith or Joe Smith, PhD. None of that. Just Joe Smith, whatever name you use to publish under or present under. The idea is that your work speaks for itself. We're not supposed to be influenced by your title. Just because I have a PhD doesn't mean my work is more persuasive or of higher quality or has more credibility necessarily. A graduate student or undergraduate student who does outstanding work is on this same level playing field as an experienced scholar who has an advanced degree. Finally, the institutional affiliation. That's if it's a part of for a university, if you're a professor or a student, if it's for a class project, you'd put the name of your university. So for example, my institution, California Baptist University. The full name of the university, I'm not putting the city or anything else, just the name of the school. So the name of the study, again using correlational language in this situation because it's not an experiment. The name of the author, let's say the student's name is Joe Smith, and the name of the school or institution, and using the example of California Baptist University. Okay, moving on to the introduction. So the introduction has been filled in for you. For this assignment, I didn't want you to spend time on a literature review and getting bogged down on that. I want you to focus on the math and the science of it. But let's take a look at the introduction so that you understand the context of what we're trying to do. That way you can analyze and interpret the findings appropriately. So life satisfaction is an overall assessment of feelings and attitudes about one's life at a particular point in time. So what are they doing here? They're defining their key term. So we have in the title, it's a predictor of life satisfaction. It sounds kind of intuitive. Well, isn't it how satisfied you are with your life? But this is defining it a little bit more precisely. So feelings and attitudes, an overall assessment. So we're not saying, well, I feel good about my relationships with my wife and children, but not so much about my job. Just an overall assessment of feelings and attitudes about one's life at a particular point in time. So it's a snapshot. So why do we care? Oftentimes in the introduction of a study, we want to make the case for why it matters. Why are we taking time to even study this? Right? Why does it matter how I feel about how satisfied I am with my life at a particular point in time? So they go on to establish the importance of the study, or the importance in this case of the dependent variable. There we go. It, referring to life satisfaction, is important because it is associated with greater academic and vocational engagement, higher self-efficacy. Self-efficacy is feeling like you can do it. You have the power to accomplish your goals. And approach-oriented achievement goals. So they're more motivated. They're more engaged. People who are satisfied with their life. So if this person is a student and they have low life satisfaction, like the person who put 1, 1, 1, 1, 1, they may not be very engaged at school. They may not be very engaged at work. That's bad for them. That's bad for the employer, for the economy. They don't feel like they can accomplish things. And they approach-oriented achievement goals. So approach-oriented goals is you're trying to work towards something. Rather trying to avoid something, you're trying to work towards something. Maybe a degree, maybe some career, maybe some relationship goal. So this person is not achieving their potential in many important respects if they experience low life satisfaction. So we're explaining why this is important, explicitly stating it. This is important because when you write academic research, don't imply things. Always be direct, clear, and explicit. Nothing can be implied. Be very clear. This is important because, and then give the reasons. Now, what about our study? Life satisfaction has been shown to differ along demographic lines. So, not everyone has equal life satisfaction. There are different demographic groups. An example of this is socioeconomic status. Some people have more money and status, better jobs than others. So what this is suggesting here is that someone in one group, maybe a group that has more resources, may have higher life satisfaction than another group, right? And again, that matters because if this group is more engaged vocationally, they feel more capable, and they are going after their goals, right? It's kind of a rich get richer, poor get poorer kind of thing, right? I'm satisfied with my life, so I'm going to keep reaching for my dreams and keep achieving. I'm not satisfied with my life, I kind of give up, right? Also age. So differences in life satisfaction between different ages. So we need to know and understand where these differences might lie because there's these important implications, because it matters, so we can prevent systematic poor results, having entire groups of people not achieving their potential the way that they could. So we want to be aware of this. All right, so we're talking about life satisfaction. We've defined that. We talked about the importance of life satisfaction. Now we've talked about that there are different between group differences between different demographic groups. Now what's going to happen is we're going to get more specific. Some prior studies have found a gender difference in life satisfaction. So when you look at an introduction, it's like a funnel. It starts broad and then kind of works its way down to more and more specific. So first we're just talking about groups, demographic groups. Now we're talking about one particular group difference, gender differences. So some prior studies have found gender differences in life satisfaction. Some have theorized that such differences have been caused by discrimination, economic equality, or other socio-political forces. So now we introduce the theory. So in any good introduction, there's a few exceptions, but typically there's going to be some kind of a theoretical framework. So we think that there's going to be a gender difference, and we think the reason for that is perhaps discrimination. Maybe one gender group is experiencing discrimination that the other group doesn't experience or experiences in a different way. And the result of this is decreased life satisfaction, which we know in turn leads to lower motivation, right? Lower self-efficacy. And that's explicitly stated here. Again, we don't imply, we always explicitly state. A gender difference in life satisfaction would be problematic because it would suggest potential inequality in opportunities for success and happiness. This person's basically disengaging and giving up on his or her goals because of this low level of life satisfaction. So this is an important concept. It matters in people's lives. There are group differences potentially. There's potentially a gender difference. Maybe this has to do with inequality or discrimination or other socio-political forces. But not all studies have found a gender difference. So some studies may say, oh, okay, so this gender has a higher life satisfaction than the other one, but that's not always the case. So this creates a need for future research or for additional research. So what we've done here is we've explained the purpose of this study. We've set the stage for this study. We're saying that because there's disagreement, not all studies are finding the same results, we need more research. So what we're going to do here is we're going to look at this question with a new sample and add to this body of literature. So we've contextualized our study in the literature and explained the need for the study. Now let's go on to our hypotheses. So we're going to talk about the null hypothesis and the alternate hypothesis. So the null hypothesis is that there is no effect or no association or no difference, depending on the statistical technique that's being used in the particular of the question. So I'm going to write the null hypothesis informally so you can get it conceptually. The null hypothesis is that men and women, so in this sample, these are adults, so we're going to say men and women have the same level of life satisfaction. So no difference, no effect, no association between gender and life satisfaction. It doesn't, right? It would be, right, gender as a predictor, we'd say, well, it doesn't predict it. That's the null hypothesis, that there's no effect. If we were to write that more mathematically, I'm still going to use common language, but written a little more mathematically. Men's life satisfaction is equal to women's life satisfaction. The null hypothesis, if once we calculate the mean of this group, the average life satisfaction for men is going to be statistically equal to the life satisfaction among these women in our sample. Now the alternate hypothesis is that we do see some kind of an effect or difference, is that men and women have different levels of life satisfaction. Okay, so our null is that they're the same. Our alternate is that they're different. Now notice that we didn't say that women will have higher life satisfaction or men will have higher life satisfaction, right? The literature has been all over the place. We don't know, so we're simply suggesting that we think there's something going on politically, something going on in our culture that's going to cause a difference. We're not exactly sure what that might be, but we're just simply exploring whether or not there is a difference. So this is a bidirectional hypothesis. So men's life satisfaction is not equal to. So that's supposed to be an equal sign with a slash through it. Women's life satisfaction. So men's life satisfaction is not equal to, right? In other words, they're different. So these are our hypotheses. So now we have introduced and conceptualized our study. Everybody knows what we're doing and why. We can move into the methods section. This is the standard organization of a research paper or research presentation. We begin with, of course, the title. Then we have an introduction / lit review section, a methods section, a results section, and then a discussion section. So this is what we're always going to expect when we're working on this kind of a project or reading this kind of a project. In the methods section, you have several different subsections. Oftentimes the first one is the participant section. So the participant section is going to describe who was in your study. It's going to give key demographic information, anything that might be relevant. This is going to give us ideas about how we can generalize these findings, right? If we have, in this case, we have a variety of ages. We'll talk about the ages. But if we had only college students, people between the ages of 18 and 22, traditional undergraduate students, that's going to limit the generalizability of our findings. What if we had all 6-year-olds, right? first graders, also going to limit the generalizability of our findings. We want to be very aware of who's in our study, how they were recruited, and again, anything else we want to know that's going to have an impact on our results. So participants were XX adults. How many adults? What percent male? What percent female? What were the ages? Mean and standard deviation. Well, where are we going to get this information from? Fortunately, this information is available in our data set, although we'll have to do just a little bit of our own work to compute and find that information. So first of all, we want to know how many adults are in the study. So everyone is over 18, so they're all adults. But how large is our sample? So each column is a variable, each row is a participant. So this is a person, this is a person, this is a person. So all we have to do is scroll down to the bottom. There's other ways to find this, but the simplest and most straightforward. Scroll to the bottom. Now this is participant number 97, but that doesn't mean there's 97 participants because some of the numbers are skipped. Right. So we look over on this over here on the left, and we see that this is number 88. So there are 88 people in our study. So there are 88 adults. What percentage are male? What percentage are female? How could we find that information? We do have the data there, but we don't want to go through and count this by hand. 1, 2, 3, 4, and do the math. We can have SPSS come up with this for us by using descriptive statistics. So I'm going to go to Analyze, Descriptives, and we're going to go to frequencies because that's what we want to know. We want to know a proportion of males and females. So I went to Analyze, Descriptives, Frequencies. That brings up this box, and the variable that I'm interested in is gender. So I'm going to click on gender and click the arrow, move it over here into the variables column, and click OK. Up comes a new window. We have an output window. So we have the data editor window, which is sort of kind of like Excel, where our data live. And over here is our output window. So it created this new window now that I've requested an analysis to be run. On our gender variable, we have data on 88 people. So you could have a situation, like let's suppose that we didn't know this person's gender. Let's see here, they just left it blank. That's how it looks in SPSS. If there's missing data, there's a little period there. Right? If this were the situation, maybe this person didn't answer that question, this would say 87 would be the sample size for this variable, and then missing 1. That would mean one person was missing data on that variable. All right, so I'm going to go ahead and put that back though. Down here is our gender table. This is our frequency table. So there are 47 females and 41 males. We're looking for the percentage. So 53% were female, 47% were male. I'm rounding to the nearest percent. Over here it says valid percent. So what's going on here is if we had some missing data on this particular variable, valid percent would be based on the number that had data on that variable, where this would be out of the entire sample. So 53%, but it's either the same because there's no missing data on this variable. Okay, so we have 53% female and and 47% male. They're in a different order, aren't they? So 88 adults, 47% male, 53% female. Between the ages of, oh, there we go again, blank and blank. So when we're analyzing a nominal or categorical variable like gender, the frequency option is often a good way to go. Ages is a ratio level variable, or age is a ratio level or scale level variable. We can analyze that beyond just percentages, and it wouldn't really be helpful to give the percentage of each age. There's so many different ages, that would be a mess. So what we want to know is the range. So who's the youngest and oldest person? What is the mean and the standard deviation? So to get that information, we're going to go to Analyze, Descriptives, and then Descriptives. So first we click Frequencies, but now we're going to Descriptives. Analyze, Descriptives, Descriptives. We click on that, and the variable we want is age. I'm going to move that over into the box and click OK. This is going to give us the information that we need. So this is more output into our output window. Descriptive statistics. So age is our variable. The N is 88 because we have data for all 88 participants on the age variable, no missing data. The minimum is 21, the maximum is 76. So we have a 21-year-old and a 76-year-old. The mean age is 37.93. The standard deviation is 13. So we're going to include that in our table. So between the ages of 21 and 76. Notice the color change. I'm going to go back and change all of the red to black, so I'm not too worried about that. The mean to the hundredths place, 37.93, and the standard deviation, 13.06, rounding to the hundredths place. So I'll go through. I'm going to change all the font to black. So participants were 88 adults. So don't leave yours red. That's tacky. 88 adults, 47% male, 53% female, between the ages of 21 and 76. Mean of 37, basically just under 38 years old. Standard deviation of 13 years. They were recruited through Amazon's Mechanical Turk, or MTurk as it's known, which is an internet-based platform where workers are paid to respond to online tasks in exchange for a small cash payment. All the participants lived in the United States. They varied in respect to level of education, high school graduate to doctorate, and annual income, less than $25,000 to $150,000 or more. So this is a very diverse group, recruited through the internet from across the United States. So they were paid a little bit of money, found through this online platform. They were making maybe some side money doing these surveys. There are people who are just high school graduates, all the way to doctorates, and some that are not making very much money, and others who are making a lot of money. All right, moving on to the procedure section. You don't need to fill anything in here, but we'll go over it. Participants completed a confidential online survey through surveygizmo.com, which included an informed consent form, a demographic questionnaire, survey questions on a variety of topics related to religiosity, spirituality, and subjective well-being. So we're only taking, again, some of the items from that larger survey for your project. Measures. So from there, we go into the measures. We only have two variables, gender and life satisfaction. So nothing else should show up in our measures section. Results, let's go back up here. Nothing should show up in our measures section. We have gender, and we should expect to see life satisfaction, right? So under measures, so first gender. Gender was measured by asking the question, are you male or female? All participants answered the question with X% identifying as male and X% identifying as female. That's the same information again, right? So we don't need to calculate anything else. So how many were male was 47%, and then female was 53%. So I'll go ahead and change the font to all be black. There we go. That was easy. Next one's a little bit more complicated. Life satisfaction. Life satisfaction was measured using the satisfaction with life scale. It contains 5 items. In most ways, my life is close to ideal. That's an example, with response options ranging from 1 to 7. So strongly disagree to strongly agree. So this is information that you should provide when you're writing about a survey instrument that you've used in your study. So you explain what the scale is, or what the name of it, what the give an example of an item, how many items there are, what the response options are, how they're anchored, and you want to give reliability and validity evidence. So the scale has demonstrated good reliability and is highly correlated with the Life Satisfaction Index A and the Philadelphia Geriatric Center Morale Scale. So right here is reliability evidence, and this is validity evidence because it's correlated with other life satisfaction scales. The scale demonstrated good internal reliability, alpha equals X, in the present study. What is going on here? Well, we have multiple items representing one construct or one variable. Remember our survey, there's not just one life satisfaction item, there's 5. So what's going to happen is these items are going to be combined into a single score. There's a few different ways to do that. You could take the average, so add 3, 2, 4, 3, 2, right, and divide by 5. So you could take the mean. You could simply add them, 3 plus 2 plus 4 plus 3 plus 2. And there are other much more complicated ways to do it, using factor analysis or item response theory. But the simplest and most straightforward way to combine these items and create a score is to add or to take the average of them. Now, what's going on here? The internal reliability was something, right? It says it was good, but we have to determine that in the present study. So alpha, Chromebox alpha, is a measure of how internally consistent the scale is. So it's the average correlation between these items. So if somebody answers high on, let's say, right over here, right? So they score a 6 on the first item. They should also probably be pretty high on the other item, 6, 6, 6. Not necessarily exactly the same. Some of these people you can see are exactly the same, all 2s, whatnot. But it should be on the higher side. So 4 is kind of on the higher side. I think that was right in the middle, right? But here we get higher, 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 middle, middle, all kind of on the middle to high range, all in the middle range. Here it's kind of middle, one's lower. Here we have 5s and 6s, and that's basically how it should work. Now, I think there were a couple that are a little off, so this was high and low. You kind of have a weird mix, but most of the time, here's 1s and 2s, they're all kind of in the high range, middle range, or low range. That's what we expect to see. We want the items to kind of work together. Because if they're all representing the same idea, life satisfaction, then you shouldn't have a lot of situations, right? Where's our scale? Where I'd say, in most ways, my life is close to ideal. Strongly agree. I'm satisfied with my life. Oh, no, I hate it. The conditions of my life are excellent. Oh, yeah. I would change nothing. No, I'd change everything, right? That wouldn't make sense. The scale would be, something would be wrong with the scale if that's happening very much. So Chromebox alpha is a single measure that we like to use. It's very common. Almost every study you read is going to report Chromebox alpha for their measures. A single simple measure of internal reliability, how associated the items are with one another. We expect them to all kind of work together to tell us something about life satisfaction. So the way we find out what Chromebox alpha is, we go to analyze and then scale. Analyze, scale, because we're analyzing this scale, the life satisfaction scale. Then we're going to go to reliability analysis. So that's the kind of analysis we want to do on this scale, is in this case, the internal reliability. There's other ways of looking at reliability, lots of other ways. They can get quite complex, believe me. But this is the simplest way, and this is what we're going to do today. So reliability analysis. So up comes this window, and it's asking which items it wants us to analyze. Don't put all of them. We only want to put the items that we believe. I'm hitting the first button, holding Shift in order to highlight all of them. So I hit Life 1, hold Shift, Life 5. You could also click the one at a time if you hit Control. It lets you do that. So a couple different ways you can highlight all 5 of them. I don't want age or gender. These are different variables, different constructs. I just want the items that go to this scale that I'm analyzing. So I click over, and the model is alpha. See, these are all different kinds of reliability coefficients you could generate. We want alpha. That's the most popular. That's the most straightforward. So 1 through 5, that's the default already was alpha, so don't change it. And then click OK. Down here at the bottom, this is the new data, the new output, I should say. Reliability statistics, Chromebox alpha for these 5 items. So the N now is not 88 people. The N is the 5 items. Is 0.938, which we're going to round to 0.94. So under this goes 0.94. I'm going to make it black, like all the other text, so it's consistent. That's really high. So the highest it can possibly go, because it's an average correlation, correlations go from 0 to 1, so alpha can only go from 0 to 1. So if all the items were perfectly correlated, it would simply be an alpha of 1, which you might think, cool, that's great, it's really high reliability. But you basically just have the same item, in this case 5 times. Each item's not giving you much new information. And in this case, the reliability is so high, we can see that these items are very similarly worded. They're really tapping the same idea. So we kind of expect this high reliability. And so that's fine for this. There could be situations where you almost would want it to be a little bit lower, so it has more breadth, covering more concepts. But here, one basic idea, What's your overall life satisfaction? In this case, 0.94. So this is high. 0.8, usually in the 0.8s people are going for. They like to see a reliability in the 0.8, and the 0.7s can be okay. 0.6 is often pushing it. Below that, with a few exceptions, below 0.6, you often won't see people using the scale, or they might be finding other ways to address it because it's not good enough. Over 0.9, we start to get, we start to be less impressed just because the items are so similar. They're not giving us a lot of new information. So usually in the 0.8, maybe 0.9 is what we're going for. So we got our two measures, gender and life satisfaction. Moving on to the last part of our method section is the analytic method. What kind of statistical analysis are we going to do to answer our research question? Okay. So to test my hypothesis, I used what, right? We have to decide what kind of test we're going to use. This test was appropriate because, and then walk through the different steps of our analysis. So let's go back to our hypotheses. Where did they go? Here they are. The null hypothesis is that men and women have the same level of life satisfaction. The alternate hypothesis, which we're testing statistically, is that their level of life satisfaction is different. So we have two groups, men and women. We have a mean for each group that we're going to calculate, the level of life satisfaction. So we're comparing the means of two groups, or simply put, comparing two means. These are independent groups. They're not paired up in any way. The men and women aren't linked based on their income level, right? You could do that. You say, oh, let's compare. This man has high income. This woman has high income. Let's pair them up. Something like that. But that's not what's happening. We have two completely independent groups. So we're going to use an independent samples t-test to compare these two means. So let's go back to our analysis slide. So to test my hypotheses, I used an independent samples t-test. Notice that the T in t-test is in italics. Why was this test appropriate, right? There's so many statistical tests. Why this one? Well, because I wanted to compare the means of two groups, men and women, and the participants were not paired in any meaningful way. Okay, so we have two independent groups. We have a mean level of life satisfaction for each one, men and women, and we want to compare those. So what are we going to do? Well, first, I will present descriptive statistics. And that's typically what we do first. We look at the descriptives, we look at the means, we look at the standard deviations. We often look at graphs or other figures that visually display the data. Second, I will test the assumptions of the t-test. Assumptions. So people like to jump right into the statistical test and find the answer. They're excited and curious. But before we run that test, we have to test those assumptions to make sure that they're tenable. Otherwise, we can't have confidence in the results. We can't skip that step. Next, what are we going to do after we test the assumptions? Well, once the assumptions have been met, right, we're going to run and interpret the results of the t-test. We'll conduct the t-test and interpret the results. Finally, what are we going to do last? We're going to calculate the effect size, interpret the practical significance of the results. So these are our basic steps. We have our descriptive statistics, sometimes visually displayed, to get an overall sense for what's going on. We test our assumptions to see if the test we plan to use is going to be appropriate for these data. Then we run the test and look at the statistical results. But remember, statistical significance is different from practical significance. We could have a situation where the men and women do differ statistically in life satisfaction, but maybe that statistical difference is so small that it doesn't really matter. It has no practical significance. So to judge that, we look at the effect size. So that's the last thing we're going to do in our analysis, is calculate the effect size. Now let's move on to the results section. Right? So main parts of our paper or our presentation is the introduction lit review section, the methods section, the results section, and then in the end we'll have the, where did it go? The discussion section down there somewhere. There it is. So now we're on to the results section. So the first thing we're going to do is look at the descriptive statistics. So what we're going to do is create a histogram of life satisfaction in the full sample. So we're just going to look at univariate statistics. Let's just look at the distribution of life satisfaction. So let's go over here and I'll show you how to do that. So here's back to our data set. And we want to create a histogram of life satisfaction, but wait, we have 5 life satisfaction variables. What do? Do we present a histogram of each of these and analyze all 5 separately? We don't want to do that, right? None of these is intended to be analyzed by itself. They're all intended to be used together as a single measure, a single scale. So we have to create what's called a composite variable out of these 5 individual scores. So the 2 simplest ways to do that are to add them or to simply find the average or the mean. We're going to find the mean and use that as our score. So how do we do that? So to do that, we go to Transform, Compute Variable. So up to the menu, Transform, Compute Variable. So we're going to be computing or calculating a brand new variable that's not in the data set yet, but we're going to use ones that are. So target variable, this is going to be the name of the new variable. So we're going to name it, let's call it life underscore satisfaction. Right? So variable names can't have spaces in them in SPSS. So I put life, L-I-F-E, underscore satisfaction. Life satisfaction. And I had to put the underscore there because it won't let me do that. It'll give me an error message. So this is going to be the name of the new variable we're creating. And we need to create a numeric expression for how we're going to compute that variable. There's a couple ways we can do this. I think it may be intuitive to write it out for you. So I'm going to put in parentheses the 5 different life satisfaction scores. So life 1, I'm going to bring it over here, plus life 2, plus life 3, plus life 4, plus life 5. So all of this is in parentheses. So we actually could leave it like this and have it simply be the sum, but we're going to make it the mean. So we take all 5 and add them and divide by, in this case, 5 because there's 5 scores. So life 1 plus life 2 plus life 3 plus life 4, all of that in parentheses for order of operations. We're going to add these first and then divide by 5. So that's a forward slash would be the symbol for dividing. All of that divided by 5, this is going to give us the arithmetic mean of those scores. There's another way you could do this using the function commands here, but this perhaps will be the most intuitive for you. We're going to click OK, and now what it's done is it has created a new variable. So look over here. In addition to the variables we already have, we have a new scale level variable, life satisfaction. For this person here, participant ID 2 or the first participant, their life satisfaction score is 2.8. So let's double check and make sure that everything worked the way we thought it would. So I'm going to do this manually. So 3 plus 2 plus 4 plus 3 plus 2. I just added up those 5 scores. All that equals 14. I'm going to divide 14 by 5, which gives us 2.8. And they just rounded to the hundreds place to 2.80. So if we were to go to any of these participants and do the same thing, we should get the score because that's what the computer just did. So now we have a single life satisfaction score for all 88 people. Didn't that save a lot of time than having to go through and do the math by hand for each and every one of them? So SPSS saved us a lot of time and computed all of those scores for us. So we're going to disregard these from now on out. From here on out. None of these individual scores are ever going to show up in our results or discussion anywhere else in our analysis. We use them to create this score, but now the only 2 variables we care about is gender and life satisfaction. We're not going to worry about ID. We never used age other than just to look at our demographics for our participant description. We don't need these anymore. So I could literally delete, I'm going to do it. I'm going to delete these and delete all these. This is all that we need. Gender and life satisfaction. Don't let anything else confuse you, right? Yours is going to look like this, because a common mistake students make is instead of using the combined score, they'll say, oh, I'm confused. I guess I'll just use this one. And they'll try to run the analyses using one of the single item scores, but that isn't what you want to do, right? It's not correct. So life satisfaction and gender, these are the only variables we're going to be working with now. So back to our template. What is it we're trying to do? Insert histogram of life satisfaction in the full sample. So full sample means not males or females separately, everybody together, all 88 people, the life satisfaction score. So here is how we do that. We're going to go to graphs and chart builder. Graphs, chart builder. Okay. It's going to come up looking like this. We want a histogram. So down here it says choose from, go down to histogram and choose the first option and drag it up to this box. Okay. So I'm going to do that again just in case you lost me. So graphs, chart builder, okay, down to histogram. There's many different kinds we can make, and there's many different types of histograms. So we're going to choose the first histogram, bring that up to here, and then now, even though it gives us the option for the y-axis, we're only interested in the x-axis. This is a univariate figure. It's given us information just about this one variable. So we're going to go to our variable list. Don't pick any of these. Don't pick the original items. Pick the new one that we made, life satisfaction, and bring it down here to the x-axis. Okay? Bring it down here to the x-axis. Nothing else, and click OK. Here comes our histogram. So this is a histogram of life satisfaction scores of our full sample. N is 88. That's everybody. The mean is 4.64. The standard deviation is 1.59 and some change. So 4.6, right, it's on a scale of 1 to 7, so right around the middle. If the middle is 4, it's just above the middle range is the average. But if we take a look at the distribution, it kind of looks like more people are reporting high levels of life satisfaction, and not as many people are reporting those very, very low levels. So there's a little bit of a skew, isn't there? How could we compare this to a normal distribution? Because that's basically what we're going to try to do. Is it because it's not exactly a bell curve, but how does that compare? So one way we can do that is to double click on it and click this button right here, and that overlays the normal curve across my figure, right? Another way I could do this is to go through the same steps I used before, graphs, chart builder, right? So here's everything we had just a moment ago. I can click on this option, display normal curve. And that also I can apply, and that's going to put the normal curve over my figure so I can compare what I actually have to a theoretical bell curve. So if you take a look, you can say, well, on this side, it kind of follows the curve, but on this side, it sticks up, right? There's a lot of cases that are higher on this end, and there's no one that's kind of over here. So we see that there's a little bit of a negative skew, a moderate negative skew. It's not extreme. It's approximately normal, kind of goes along the normal curve, but there's a little bit of a negative skew here. So we're going to copy and paste this into our template right over here. So I'm going to delete the instructions. To copy and paste this, I'm going to right click on it. I'm going to go to copy special. Okay. And then I want an image. Now yours, if this is the first time you've used the program, you might have some different options here. I'm going to go to image, and if you want it to stay that way, save as default. So it's a JPEG image, click OK. Now it's been copied. I'm going to come over here and right click and paste. All right. So I'm going to copy and paste that into my template. Right. I want to get rid of this over here on the right. It's taking up too much room. I want to write some information here. It's kind of in the way. So to do that, I'm going to double click on it and go to crop and just bring that in a little bit here. so that I don't need that information on the side, so that I can have a little more space to write my information over here. No, I'll just put it like that. That's fine. Okay, so let's say something. I guess I'll cover up that box behind it. I'll say something about this histogram. So in the full sample, life satisfaction was approximately normally distributed with a moderate negative skew. Most respondents reported respondents, there we go, reported moderate to high levels, with only a few reporting low levels of life satisfaction. Okay, so it's approximately normal, kind of goes along the curve, but a little bit of a negative skew. The skew is the tail, so if you were to look at this as some sort of creature, the tail would be over here, where it's a little bit skinnier. Head would be, I suppose, on this side. So the skew is the tail, a moderate negative skew. So that's what it looks like in the full sample. All right, let's move on to the next slide, descriptive statistics. Now it wants us to include a descriptive statistics table for life satisfaction. So it wants us to give the mean score and the standard deviation and interpret that. What does that mean? Okay, so to do that, we'll go back over here. We're going to go to Analyze Descriptives. Now our new life satisfaction variable is a ratio or scale level variable. So to analyze that, we're going to use the descriptives option, because we don't want proportions, we don't want frequencies. I don't want to know what percentage picked I had a score of 5.60, right? There's too many different ones. So I want to go to descriptives, and I don't need age anymore. I'm done with that. So I'm going to go get rid of it and bring over life satisfaction. Click OK. Here is my new descriptives table. So I'm going to right click, copy special. If yours is set to something else, right, yours might look like that perhaps. Just click on image, get rid of everything else, save as default. So in the future, right, you won't have to keep clicking all the buttons. Click OK. I'm going to go back to my template and go ahead and get rid of those the instructions, and paste that here. So I'll just go ahead and there we go. Put it inside that box. That's fine. Make it maybe a little bit smaller so it fits in the box. That works. Looks good. Try to make yours look nice. Don't spend all day making everything look exactly perfect if you're stressed about just learning the material, but try to make it look good. You want to be professional. So our range was 1 to 7, because some people put all ones. Remember that earlier we were looking at those 1, 1, 1, 1, 1. So if you add all that up, that's 5. Divide by 5 is 1. Some people put all 7s. Add that up, that's 35. Divide by 5 is 7. So our range was 1 to 7. The mean life satisfaction score was 4.64. Got that right here. I'm rounding to the hundreds place. The standard deviation, 1 point, and I'm going to round 60. So I'm rounding again to the hundreds place. So 0.5986 rounds to 1.60. So the mean score 4.64, standard deviation 1.60, indicating that, what does this mean? So what is a score of 4.64? So we'll go back over here. So 4 is neither agree nor disagree, and 5 is slightly agree. So let's see, 4.6 would be a little closer to a 5. So is slightly agree. So indicating that the average participant slightly agreed with the 5 life satisfaction statements. So the average person, right, our average participant here, was in a slight agreement. Yes, I slightly agree that I'm satisfied with my life. Okay, fair enough. And I'm going to change this to a black font. There we go. So everything matches. Okay. With the rounding, I picked the hundreds place. That's pretty common. One note: be consistent with that. So you wouldn't put 4.64 and then do that. That looks awful. So be consistent with your rounding. If you do the hundreds place, then do that consistently. Okay. Next slide. So we've done univariate figure, univariate descriptive statistics. Now we have what do we want here? A box plot of life satisfaction with gender on the x-axis. So now we have a bivariate figure. We're going to get a visual sense of how the genders compare on life satisfaction. So this is going to be the first glimpse we get into the answer to our research question. Visually, what does this look like? It should be interesting. Are men more satisfied with their lives, or are women more satisfied with their lives? We had some thoughts about gender inequality, discrimination. Maybe you're thinking, this gender faces more discrimination. They're probably going to be less satisfied with our lives. But we're curious. So this is going to be the first picture, literal first picture we get of this relationship. So how do we create this? I'm going to go back over to SPSS. We're going to go to Graphs and Chart Builder like we did before for the histogram. But we're not going to make a histogram this time. We're going to make a box plot. So choose box plot and then choose the first box plot image and drag that up here. All right. And so now the normal curve is gone, right? It's a whole different kind of figure. We have an x-axis and a y-axis. Typically in a figure, the independent variable goes on the x-axis, the dependent variable goes on the y-axis. Also in a box plot, because the nature of the graph, it has to be a scale level or continuous variable here and a nominal or categorical variable here. That works out perfectly. So gender goes on the x-axis. We're going to be comparing females and males. So our independent variable is gender. It's predicting our outcome. Male and female, two different groups. It's a categorical variable. And our x-axis is going to be life satisfaction. Don't choose any of these. Again, we're never going to use the original variables again once we create the composite score. So life satisfaction is going to go on the y-axis. Gender is predicting life satisfaction. We're going to get two side-by-side box plots comparing these genders. Let's see what happens. Click OK. Here it is. Let's take a look at this figure. So we have females on the left, males on the right. The box plot gives us the range, the lowest and highest score. So we can see that females range from 1, right, 0, 2, so 1 would be right here. So from 1 to 7. So you probably had a female that put all 1s and a female that put all 7s, so they have the full range. This is the interquartile range, is where the actual box is. And then the dark line in the middle, that's the median. So it looks like a female's median score is maybe a little bit over 5 and some change. Okay. Over here we have the males. The range is the same. We have males putting all 1s, males putting all 7s, so we have the full range. The interquartile range, though, is a little bit lower than the females, and the median also appears to be a little bit lower. What is that? Maybe about, this looks like it's a little less than 5, so a little over 5, a little less than 5. Male and female. We're going to copy this. I'm going to hit copy special. I want that to make sure that's an image. Click OK. I'm going to drop that into my template. If you're having trouble copying and pasting the way I am, sometimes users of Macs have some trouble with that function in SPSS. Another option would be to take a screenshot and crop that screenshot. So if you're using a Mac and that function is not working for you, go ahead and Google, how to do if you don't know how to do a screenshot on a Mac or in a Mac OS, whatever you're using, and then follow those instructions, in which case it would give you a picture of the entire screen that you would paste, and you would crop that down to just the figure we're interested in. Okay, but make sure you get a nice image of that figure in there. Don't take a picture with your cell phone and upload that. I've had people actually take a picture of the screen and put that into their document. That's no good. So we need to get it in either the way I'm showing you or through a screenshot if you're using the Mac platform. Okay, so what are we going to say about this box plot? Well, on average, women's scores appear to be slightly higher than men's scores. Men's scores were more normally distributed, with women's scores demonstrating a stronger negative skew. So that's a good point too. So you look at this, it kind of follows the normal curve. It's on its side, but imagine the histogram on its side. It follows it a little more normally. It's a little more balanced, more symmetrical. Over here, though, we have a bit of a stronger skew. So most of the women are up here at the top, but there are some. If we were to draw a histogram, it would kind of come like this, and then the tail would drag out here. So there are women on the very low end, but for the most part, women are scoring on the high end. They're satisfied with their lives. Men, again, on average, yes, but less so. And more of the men are less satisfied with their lives. So we're not going to get into interpretation yet, but if you had predicted that maybe you thought, well, I think women are going to have lower life satisfaction. So far, the data don't seem to be consistent with that, but we're not going to draw any conclusions yet, but it is interesting to see the picture. Moving on, descriptive statistics. Remember before we had a graph, and then we had the numbers? Same thing here. So we have a graph of this relationship. Now we're going to look at the numbers. We're going to compare the mean and standard deviation of the scores for the two groups. So insert descriptive statistics table for life satisfaction separated by gender. So before, this is not separated. This is the whole sample, all 88, mean standard deviation. Now let's look at it by gender. How do we do that? We'll go back to SPSS. Analyze, compare means. So not descriptive statistics again, compare means, because that's what we're going to do. Analyze, we're going to compare the means of the males and females, not statistically yet. We're not going to run a statistical test. We're just going to calculate the means. So analyze, compare means, means. Analyze, compare means, means. Independent and dependent variables. Our independent variable is gender, and that is predicting our outcome, life satisfaction. Again, make sure that you use the composite variable that you created. Don't use any of these. You need to use this one, or else it's a mess. And we'll click OK. So now we have this table here at the bottom. I'm going to copy special. I'm going to paste that into my, there we go, into my template. Kind of center it, make it look nice. There we go. So we have the mean for females, the mean for males, the total mean. Now the total, all 88, this should be exactly the same as what we had before, 4.64 and 1.6, 4.64, 1.6. If these are changing, something is wrong. So you can confirm to make sure that's what you already had before. Now we have female and male. So the mean life satisfaction score for women was 4.88. The standard deviation for women was 1.62. The mean score for men was 4.37. I'm rounding to the hundreds place, so because of the 5, let's move it up to 7, 4.37. The standard deviation for men, 1.55. Okay. So the mean for women, 4.8. The mean for men, 4.3. Let's interpret these scores. So on average, women tended to slightly agree, right? Because that's what well, this would round to a 5, right? So if we look back at the original scale, on average, women are kind of in this 5 range. They tended to slightly agree with these items. Whereas the men, right, at 4.3, they're closer to the 4. They tended to neither agree nor disagree. They're on the fence. Do I like my life or not? I don't know. Women seem to be, on average, tending to agree, or at least slightly agree, with the life satisfaction statements. Whereas men neither agreed nor disagreed with the statements. Okay. I'm going to go ahead and make all of the text black so it's even, uniform, it looks good. Okay, so we've looked at this table, we've interpreted that. So now we have a sense for which group at least appears to be higher. And females appear to have higher life satisfaction. So we didn't have a directional hypothesis. We just hypothesized, if we go back to our hypotheses, that they were different. So far they seem to be different. We don't know if they're statistically or practically different, but the observed difference is that the women is higher, that their satisfaction is higher. Here we go. Okay. But we don't know, again, if it's statistically significantly different. It could be a statistical tie. Also, we have to take a look at the standard deviations to get a sense for the effect size. Is the observed difference between 4.36 and 4.88, is that meaningful or not? All right, so the next step is to look at statistical significance. We need to run the t-test, but we have to check the assumptions, don't we? So the assumptions of a t-test are going to be normality, We're going to look at a histogram of both of those scores and make sure they're roughly, approximately normal. Absence of outliers. Homogeneity of variance. We'll talk about each of these as we go along. And then we'll be able to actually run the t-test. We're going to check homogeneity of variance, absence of outliers, and normality. So insert histogram of women's life satisfaction scores. So before we had a histogram of everybody, and they're all on the whole approximately normal. But remember over here, they looked like they're a little bit more skewed. So let's actually check that out visually. We got to create a histogram of just the women and then a histogram of just the men. How are we going to do that? Let's go back to SPSS. We're going to go to graphs. Actually, don't go to graphs yet. We need to select just the females or just the males. So what do we want first? Women. We want females first. Okay. So we're going to go to Data, Select Cases. Data, Select Cases. I'm going to tell it, I want you to select not all cases. I only want you to select the cases if a certain condition is satisfied. If, I'm going to click on the if, to select cases, and then if what? If gender, click the arrow, equals, well, I want women first. If you remember from before, women were coded 0, right? Female was 0, males were 1. So gender equals 0. You don't put this, gender equals female, right? We had to code it. It's a numeric variable. If you put gender equals female, it's going to confuse it. Gender equals 0. Click continue and OK. Now, when you take a look at your data set, if you take a look at the data view, you should see all of the men crossed out and all the women, the females, not crossed out. See that? Male, crossed out, crossed out, crossed out, right? Back to female, and so forth. So the males are crossed out, the females aren't. So now any analysis I run, any figure I create, is only going to be conducted with the females. It's as though the males don't even exist in this data set. It would be as though I deleted them. Also notice it created a new variable, a filter variable. It's coded 0 and 1 as well. 1 equals selected and 0 equals not selected. So it created that when I ran that select cases function. So now I'll go to graphs, chart builder, back to histogram again, the first histogram. And I'm going to put life satisfaction on the X. So it's going to be just like before, except instead of making a histogram for everybody, it's going to make it just for females. Notice that the N is 47. It's 47 females. So I'm going to go ahead and copy that and paste it here. I'm going to crop out the information at the top right, and make it smaller so that it fits over here in my box. Let's go with that. So these are the women's scores. All right. What about the men's scores? You know what? Let's go ahead and add that. Why don't we add that normal curve to it? I think that's going to help us interpret it. So I'm going to do it again. Exact same process, but I'm going to click the Display Normal Curve button, Apply, and OK. There we go. Copy that, bring it over, delete the first one I made. Same process. I double click to crop it. There we go. And then we'll make it smaller and stick it smaller yet inside my box. There we go. So there's my women's scores compared to the normal curve. Now the men's scores. We'll go back over here. Data, select cases. Don't forget to change it. If you forget about this and continue the assignment, it's going to be a mess. So select cases. Now, if the condition is satisfied, if gender equals 1, click continue. Okay. Now it's inverted. All the females are crossed out and all the males are not crossed out. Every analysis I run henceforth will be conducted only with the males, as though the females have been deleted from the data set. Graphs, chart builder. Everything else can stay the same. Normal curve is still selected. I click OK. And the new graph is only for the males. N is 41. Copy special. And we'll take it over to our template. I'm going to crop out the information at the top right to get it to fit a little bit more nicely. and shrink it a little bit more than that even, and drop it into my box. So here's my female scores, here's my men's scores. We want to say something about the normality. We're looking for approximate normality. It just needs to not be radically violated. So a huge, tremendous skew, a very unusual distribution. As long as it more or less follows this curve, we're okay. The t-test is robust to moderate violations of normality. And there's a level of subjectivity in interpreting these histograms. So let's go ahead and make a note. So discussing the assumption of normality, the two histograms are approximately normally distributed, right? Although the distribution of women's scores has an apparent moderate negative skew, the assumption of normality is supported. So there's a, it looks like there appears to be a moderate negative skew. There's a few over here on the lower end, more on the higher end. Same kind of thing over here. They're not, the t-test is what's called robust to those, to moderate violations of normality. It means the test will still work. We can still trust the results as long as it's kind of close. Okay, so the first assumption has been met. We can move on to the next assumption, absence of outliers. So to look for outliers, there's a few different ways we can go about that. One easy visual way to inspect for outliers is to look at the box plot. We've already made box plots, so I'm going to pop up a couple slides up here to the box plots we created. On a box plot, potential outliers will be identified because they fall outside the whiskers. So we have the box and whiskers here. If we have an observation that's more than 3/2 the interquartile range from the median, it'll be identified on SPSS by either a circle or an asterisk. They don't appear on this box plot. Similarly, we can take a look at the histograms. On a histogram, an outlier is identified by looking for a lot of white space between the observation, or maybe one or two observations, and the next largest or smaller observation. So for example, if we had an observation over here, a 9, or over here, I don't know, a -2, that would be an outlier. Here we have the full range represented. There's not a lot of room for outliers, but that's what it might look like. An observation over here, an observation over here, here, or over here. So we don't see an indication of outliers based on a visual inspection of the box plot or even of the histograms. So we can say that a visual inspection of box plots and histograms reveals no conspicuous outliers. The assumption of absence of outliers is supported. So as you're going through your analysis, preparing for your t-test, we're addressing these assumptions, and we're going to explicitly state this first assumption is supported. And here's how we tested the second assumption. We find that it is supported. One more assumption, homogeneity of variance. Okay? So what's going on here is we want, before we can interpret the results of the test, we're assuming that we're checking the assumption that the variation between the two groups is the same. The variation within the female sample is equal to the variation within the male sample. Take a look at the standard deviations. The female standard deviation is 1.6 versus 1.55. The female standard deviation is higher, but is it statistically higher? So there is a way of testing this. And when we run our independent samples t-test, it actually includes that because it's such a common, something we commonly need to know. It's such an important assumption that they include that in the output. And if the assumption is violated, they even give you a corrected score, a corrected t-test value, I should say, in the event that it is violated. So it takes care of that for us, but we still need to address it. So how do we do that? Let's go down, go back to SPSS. Now we still have only the male selected. If we try to run the t-test without changing the data select cases option to everybody, it's not going to work because as far as SPSS is concerned at this point, there are only males. So if you say compare males to females, it's going to say, I don't know what you're talking about, buddy. You only have males in your sample. So we have to go to data, select cases, all cases. Click OK. This filter variable still exists, but it's not being used. Everyone is selected. You can even delete this if you want to. You can click on it and hit delete if it bothers you. It'll go away. Now we're going to go to Analyze, Compare Means. Look at the different tests we have. One sample t-test, independent samples t-test, summary independent samples t-test, paired samples t-test, and analysis of variance. We want the independent samples t-test. We talked about that earlier because we have two means being compared. That's our t-test versus, for example, analysis of variance, more than two means. And we have two independent groups. They're not paired up in any way. So independent samples t-test brings up this dialog. So the grouping variable, that's our independent variable, which is gender. Bring that over here. It has gender and then question mark, and the button define groups. Use specified groups, group 1, group 2. Now in this situation, we only have two groups, right? There's only two genders, male, female. But if we had something like color, we were comparing maybe the resale value of different color cars, red, blue, and green, and we wanted to run a t-test, as well, you can only compare two means. You want to compare red and blue, green and blue, red and green. What are you going for here? SPSS isn't smart enough to figure out in this situation that there are only two groups and kind of skip this question. You still have to tell it. So we have group 1 and group 2. Don't do this, right? Or I'm trying, it won't let me. I was trying to write male, but it won't let me. It has to be a numeric variable that's been coded. So we have female is 0, male is 1, so you have to use those codes. If you're doing this on your own and you forgot how the variable has been coded, you have to go out of this dialog box, go back to the variable view and check. Or you could click on the toggle switch here in the data view and check. But you need to know what those codes are. In this case, 0 and 1 and continue. Now it's happy. But we still need a test variable. What are we comparing the gender groups on? Life satisfaction, of course. Don't use the original items. Use the one that you created based on all the original items. Bring that here. So this is going to compare life satisfaction based on the grouping variable, the independent variable of gender. We click OK. Up comes a couple of tables. This first table is giving us descriptive statistics by group. Females average is 4.88, males average is 4.36. That should look familiar. We saw that earlier. Standard deviation, right? We just looked at that a moment ago. So this is old news. This is the new information. This is the actual t-test results. And here is Levine's test for equality of variances. So this is what I'm interested in first. So I'm going to bring the table over, but I'm not going to get into anything else yet. I'm just going to focus on this first section. So we'll crop it. So I'm going to copy that and bring it to my PowerPoint. I'm going to crop in to just Levine's test. That's all I'm interested in at this precise moment. So see how I'm focusing on just this part of the output. Make it a little bit bigger, and voila, homogeneity of variance. So this confuses a lot of students because it's a lot of backwards thinking. It's like opposite day. Here's what I mean by that. If the assumption is supported, then the test is not significant. Or if the test is not significant, then it is supported because they're not significantly different. Right, so it's a lot of crisscross thinking there. So what this test is doing is it's testing to see if the two variances, the variance in the female group versus the variance in the male group, are significantly different. Our threshold for significance is 0.05. So if P is less than 0.05, then they're significantly different. But we don't want them to be significantly different. We want them to be the same. We want them to be homogeneous. We want the variance to be homogeneous, the same. So if this is significantly, if this is significant and the variance is significantly different, then our assumption has been violated, and we'll have to address that. But here, our significance level is 0.968. It's really high, meaning it's really not significant. So the groups are really close to equal in terms of their variance. Wow, that's a lot to follow. So let's write that out. Hopefully you can track with me, or almost track with me. So Levine's test for equality of variances was non-significant, right? So P was 0.97. It has to be less than 0.05 to be significant, so it's not even close. If it had been 0.06 or 0.08 or even 0.10, we'd say, well, it was close. We'd still be okay with it, but it would be closer. This is not even close. It's a not significant test by a long shot, indicating what? That the variances of the two groups were not significantly different. In other words, they were the same. Statistically, they were the same. They were homogeneous. That's what we're going for. The assumption of homogeneity of variance was supported. That's what this is telling us. That because they're not significantly different, they're the same. We want them to be the same. Homogeneous means the same, right? That's what we're going for. So the assumption is supported. That's a little bit tricky. So you can think about that, maybe review that a couple different times, or as you go along, hopefully it'll make more and more sense. But that is our final assumption. So now that all of our assumptions, we have normality, absence of outliers, homogeneity of variance, all of these assumptions have been supported, we can move forward, finally run our independent samples t-test, which we did, but now we'll actually look at the results, and we'll analyze and draw our conclusions. So back to SPSS. Here's the same table. I don't need to run it again. I just did it. But in case you want to, analyze, compare means, independent samples t-test, right? Gender was our grouping variable or independent variable, defined as 0 for females, 1 for males. Our test variable, our dependent variable, is life satisfaction. And here we go. It's exactly the same thing. So let's take a look at this. So we already looked at Levine's test. And then we have two different rows. We have equal variance assumed and equal variance not assumed. So over here, these are our test results. And we get them twice based on whether or not the assumption has been met. So if this had been statistically significant, in other words, they were not equal variances, we'd interpret the bottom row. Since they are equal, because they're not significantly different, we interpret the top row. So we're interested in here over. All right, let's go ahead and copy and paste that into our PowerPoint. So here's our output. Oh boy, that's a lot. So let me go to crop. This bottom row, equal variance, is not assumed. So if that last assumption had not been met, we would ignore the top row and just focus on this. In our case, we're going to ignore the bottom row because the assumption has been met. And to make our lives easier in terms of interpreting the output, we're going to crop out this Levine stuff because we already looked at that in the last slide. There we go. And then I'll crop out that title so I can make this bigger and hopefully a little easier for you to read. Okay, so this is the output we're primarily interested in. We have the t-statistic, the degrees of freedom. Because it's an independent samples t-test, the degrees of freedom is n-2 for the two groups. The significance level, we'll zero in on that in a second. The mean difference and the confidence interval of that difference. Okay, so the difference between the means was how much? 0.515. So where did they get that from? That's the difference between 4.8809 and 4.3659, 0.515. So it's just telling us if you subtract males from females, that's what you get in terms of the observed means. Okay, fair enough. But is that difference statistically significant? We're going to zero in on the significance level. This is the p-value, which is 0.132. Now, with the Levine's test, it was 0.96. It was way out there. It's a lot lower, but is it significant? Well, to be significant, it has to be less than what? 0.05. Is 0.13 less than 0.05? It's not. Now it's closer. It's not way off, but it hasn't quite passed that threshold for significance. So we will say the difference between the means was not statistically significant. Now you could just leave it right there with a period, or you could provide the reader with the exact details, which is a nice thing to do. Certainly in this case, when we can see that the significance level was at least kind of sort of close. Here, how do we report this then? It's part of the same sentence separated by a comma. We have T in italics, the degrees of freedom, which is 86, that's in parentheses, space, equal sign, space, the test statistic, 1.52, because I'm rounding to the hundreds place, comma, space, P in italics, space, equals, space, 0.13, period. So that's the p-value to the hundreds place as well. So when you're reporting non-significant results, you would report as p equals and tell the reader exactly what it is. If it's significant, oftentimes you would see this. P is less than 0.05 if it were significant. It's not, so this is wrong. But here we're saying P equals 0.13. Nowadays, a lot of times people like to report the exact value, even to the thousandths place, even if it is significant, so the reader can see exactly where that fell. Is it 0.04999999, it just barely crossed it, or is it 0.0002? They like to be more precise nowadays. But here, this tells the reader it's not statistically significant, so this is a statistical tie. It's kind of close to being significantly different, but not quite there. So men and women reported equal levels of life satisfaction. Therefore, I failed to reject the null hypothesis. There you go. So the null hypothesis is that they're equal. The alternate hypothesis is that they're not equal. If we have a lot of evidence for the alternate hypothesis, if p is less than 0.05, meaning that it's very unlikely we'd find this difference if this were true, then we'd reject the null hypothesis. But we don't have that evidence. We could have found that test statistic by chance, right? So we don't have enough evidence to reject this null hypothesis. So we're going to sort of stick with that. We're going to retain the null hypothesis that they are the same. Okay, go back where I left off. Okay. Now, we're not going to stop there. We're going to look at one more thing. We're going to look at the effect size. We want to know, was the observed difference that 0.515? Did that even matter? What if this had been less than 0.05? Would that difference even make a difference? Make a practical difference? Does it even matter? So we look at that in terms of effect size. To calculate the effect size for the difference between two means, we use Cohen's d. And that's where you take the difference between the means and you divide by the pooled standard deviation. So the standard deviation of the two groups combined. Okay? And this is going to give us the effect size coefficient. So to get this information, to calculate this, we need to know the difference between the means and the pooled, as well as the pooled standard deviation, or the standard deviation of the entire sample. So to get that, we've done this before, but we can get it again. Analyze, compare means, right? Same information, gender is our independent variable, life satisfaction our dependent variable. It's going to give us this table here. We'll copy this, and we'll drop this into our presentation. There we go. So the difference between the means is, if I recall, was 0.515. So I'll put that right there, 515. By the pooled standard deviation, so the standard deviation of the entire total sample is let's say 1.60. We'll round this to, why not? Be consistent. So 0.52 divided by 1.60, that's the standard deviation of the entire sample. This produced an effect size, Cohen's d of what? So 0.52 divided by 1.60 is 0.33. So this is, what this is the difference in standard deviation units. So when we talk about how important an effect is, how big an effect is, we look at it relative to the standard deviation. So the difference between males and females was about a third of a standard deviation. So what does that mean? Well, we have Cohen has certain criteria for effect size. What's a small, medium, and large effect size? Well, you can always look this up if you don't remember. Cohen suggested D of 0.2 is a small effect, 0.5 is a medium effect, and a 0.8 or larger is a large effect. So if two group means don't differ by 0.2 standard deviations or more, the difference is trivial, even if it's statistically significant. If it's about 0.2, it's on the smaller side. Not until we get to about 0.5 do we have even a medium effect. So we have 0.33. So it's definitely on the smaller side. Not trivial, but it is on the smaller side, indicating a small to medium effect because it's between the 0.2 and the 0.5. So it's definitely on the smaller side, small to medium effect. It's not very practically significant as well as being not statistically significant. Go ahead and change the font to black. We'll move on to the last section of our paper, the discussion section, where we're going to summarize and interpret these results. So in the study, I compared men's and women's levels of life satisfaction. Blank group tended to report higher levels. Well, which group tended to report higher levels, right? Or higher observed levels were among the women than men. However, the difference was only small to medium and statistically non-significant. So women's observed scores were higher, and they weren't a lot higher, and they weren't statistically significantly higher. These findings are blank. So are they consistent or inconsistent with prior literature, which has found a gender difference? So if they did find a difference, did we find a difference? No. Even though there was an observed difference, yes, one value was higher than the other, women's value was higher, it wasn't practically different and it wasn't statistically significantly different. So if someone else did find a difference, our findings are inconsistent with theirs. So it's always important to interpret your results in light of prior literature. Is it consistent or inconsistent with what other people have found? Also, we want to interpret our findings in light of theory. These findings, do they support or do they not support the theory that socio-political inequality has negatively affected the life satisfaction of either gender? Right? Well, they don't support that theory, do not support the theory, because we didn't find a difference. Right? So we can't say that this inequality is causing this difference in life satisfaction because there was no difference in life satisfaction. Right? So they don't support that theory. So we've summarized our findings in non-technical language. When you're in your discussion, don't include any statistical or technical language. Just put it in everyday language. We interpret our findings in light of prior literature, and we interpret our findings in light of theory. Now what? We move on in our discussion, and we're going to talk about implications. So what do we actually do with this information? So feel free to develop your own ideas about the implications of the study, but we'll go ahead and give a suggestion. When addressing issues related to poor life satisfaction, mental health professionals should explore causes other than gender. Right? We're not seeing that this is really a factor. So if someone comes in and says, I'm just unhappy, you shouldn't, with my life, I'm not satisfied. Well, you are a male or you are a female. That does kind of make sense. Well, that may not be what's at the root of this. Let's look at causes outside of gender. What are other forces and variables that could be at play? Right? So we could develop that further. I just want to get the main ideas across here. So you have some kind of implication of the study. What do we do with the results? Next, limitations of the study. Right? So how was usually we look at the methodology. So in what ways was the methodology limited? Well, one example of that, the study was limited in that the entire sample was drawn from the United States. Perhaps if we drew from a different country where gender inequality was more pronounced, we would find different results. But because we were sampling from a Western country, or we have gender equality, perhaps we don't find this effect. Right. Finally, we end with future research. We're making suggestions not for what practitioners should do, but what future researchers should do. How can we carry on or extend this research? So I'll give you an example of that. Future research should explore this question in different cultural contexts. See, there's often a connection between the limitations and suggestions for future research. You say, well, here's the problem with this study. Somebody else should fix that problem in the future. To determine whether results differ when overt gender discrimination is present. Right? So we could see in some other cultural context, some other country, very different results. So we want to think about how our sample, how our methodology could have influenced the results and how that could be addressed in the future. Now, typically a reference slide would appear last. We'd end with some references. We have several cases where we've made factual statements that aren't cited. I simply wanted to simplify this project and focus on the math, focus on the discussion and the implications and the interpretation of the data without getting into the references and the prior literature in detail. But if you were formally presenting at a conference, you would be expected to provide citations and references for all of your factual statements, certainly with regard to prior literature. Hopefully this was helpful to you. It makes a lot of sense, and you can use this as an example as you move forward on to your final project. Thank you.